just another minute or two. Please make as much progress as you can on the 6 basic functions. I'm going to get started. So if you're still working, keep working. That's fine. So again, I hope you took my advice and at least one time practiced graphing these. You may have noticed on the Canvas page for this, there is a sheet of graph paper that I have like 4 or 6 of these grids blank on it. You can print out. If you don't have a printer, you don't want any, see me after class. I'll print out a dozen for you and you can practice a bunch of times. So I would give you the same advice because this is not going away. As part of your homework in the next week, because we're not going to see each other for a week after this. Yay, 3-day weekend. Make sure that you practice at least once. I would say once or twice, but practice at least once doing this the best you can from memory. That is one of the best things you can do if you want to be successful on the next test. If you had to write down the tables of values, that's fantastic. Do whatever it takes. But I'm just going to go ahead and remind you, this is the squaring function. So whatever x value I use, I'm going to go ahead and I'm going to square it. So here goes. I'm going to start over here at the right side. When I square 3, I get 9. When I square 2, I get 4. When I square 1, I get 1. When I square 0, I get 0. -1 squared is 1. -2 squared is 4. And -3 squared is 9. And there's my basic points of my basic graph. And now I'm just going to connect the dots. I can't talk and write, but I'm trying anyway. Not bad, not bad. That's the graph of the year right there. Okay, so there is my parabola. It's a rounded shape down at the bottom. Questions, comments, or concerns as you were going through this? Do you have anything we need to clarify about our parabola, our square graph here, squaring function? I'm going to go next to the absolute value function. Okay, these are in no particular order. They were just in the order that I cut and pasted from last time's sheet. The absolute value, you told me last time, the absolute value just takes any input and makes it positive. So I'm just going to go and pick some values from left to right, and I'm going to take the absolute value. So absolute value of -5 is 5. The absolute value of -3 is 3. The absolute value of -1 is 1. 0 gives me 0. Absolute value of 2 is 2. And one more for fun, absolute value of 6 is 6. Unlike the squaring function, the absolute value function is straight, comes down to a point. Okay, so it's a nice V shape. Again, before I move on, I just want to make sure that we are getting a little more comfortable. Is there a question or anything about the absolute value graph? The next one's the cubic function. All you're going to do is any input, you multiply it by itself 3 times. So when I do 2, 2 times 2 times 2 gives me 8. 1 times 1 gives me, or 1 times 1 times 1 gives me 1, 0, -1 times -1 times -1 is -1, and then -2 times -2 times -2 is -8. Remember, the function is not limited to these inputs. We talked about the domain and the range last time. The only limitation I have is the size of my grid. If I put 3 in there, 3 times 3 times 3 is 27, and I don't have space for that. So this graph just represents what's happening right around the origin, which usually for a lot of graphs, that's where the fun stuff happens. The square root graph. If you remember last time, the square root graph is the only one of the 6 basic functions that has a limited domain. Where does my domain start for the square root graph? 0, exactly. So I'm just going to pick numbers. I'm going to pick inputs that are easy to take the square root of without getting decimals or simplifying. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And finally, the square root of 9 ends up being 3. And those are my graphs. And this is a parabola that's been cut in half, and it's on its side. Flipping to page 2, last 2. The cube root function. Again, just like the square root function, I'm going to pick inputs that are nice and relaxing to take the cube root of. So I'm going to start all the way down here on the left with -8. Cube root of -8 is -2. The cube root of -1 is -1. 0 is 0. Cube root of 1 is 1. And then the cube root of 8 is 2. So here is my shape. Excellent. Great graph. Not good arrows, though, on the end. Looks like it kind of bumped into a wall there. And then the last graph is the identity graph. My function is just equal to x, and so the input is equal to the output. So whatever is clever, I'm just gonna go ahead, 7, 7, 3, 3, 0, 0, -2, -2, and one more for fun, -5, -5. And not bad for a freehand straight line. Okay, those are my 6 basic graphs. Practice them, because today is the first day that we are going to now do things with these 6 basic graphs. And the things we do are going to gradually get a little bit more complicated as we go through this semester. What we're going to talk about today is translations. And a translation is just a shift. Okay, that's all it means. When we come back a week from today, on Wednesday next, we're going to talk about stretching and shrinking of our basic graphs. Okay, and how I know when I see a function that these things have been done. So before I tell you what a vertical translation is, before I tell you how to recognize it, here's just a little bit of trivia. When you see this notation, f of x or g of x or h of x, whatever the letter used to denote the function, I know that this x value, this is my input. And you've answered this question before when we talked about functions on the second day of class. What is this notation telling me? What value does that represent? Represents the y value. Okay, so just want to remind you of that. That notation, function notation, is just a fancy way to represent the y value. And the reason I mention that is because what we're going to see with vertical, wave your hand. Which way does vertical represent? Yeah, vertical is this way. If you're a Florida State Seminole, boo, then you're used to doing this with your hands, okay? So that's vertical. Up and down is the vertical direction. So we're going to start with that. Now, how do I recognize it? Well, what you're going to see is you're going to see your function, that y value. Then outside of the function, you're going to see something like this, +5. So what this is telling you, what you're seeing here, is you're seeing your y values, and then I'm going to add 5 to all of my y values. So if I have a y value and I add 5 to it, which way is that going to go? Up, right? When I add numbers to my y values, they are just going to go up and up. So you have just basically described for me a vertical translation. Now I'm going to show you, if you were to read the book, if you go into My Math Lab and click on the ebook and you look at this, this is how you will recognize vertical translations. So if I have a value of c, a constant, okay, c just represents a constant. If I have a value of c greater than 0, then this is what you'll see. Okay, if I take f of x plus c, like you just told me with the +5, you said when I add 5 to all of my y values, that's going to move the function up. You are 100% correct. What this represents, a translation up. C units. You just told me that with this number plus 5, you said that's going to move the function up 5 units. And so all this is said is just in general, with the value C is going to represent a translation up of whatever value C is. Did I lose anybody on the lingo? Are we doing okay? I want you to be solid. I'm hoping today is nice and smooth. And if it's not, I hope you raise your hand and let me know. How do you think we're going to move the function down then? If plus C moves the function up, then what? Yeah, subtracting from my y value. So f of x minus C represents f of x minus C represents a translation down C units. So what we're going to do for this, there's 2 bits today. Recognizing vertical translations, which we've just defined, and now we're going to do a bunch of examples to get you familiar with that. And then we're going to say, how do I recognize horizontal translations? And we're going to do a bunch of examples to familiarize you with that. So whenever you have a question, please let me know, and we'll see how we do. So my first example here, example 1, I have given you the graph of a function, and what we're going to do is we're going to use that definition that you can't see, but I think you have written down to write the equation of this function. Okay, so this is just the first task that I have. So I want to know what is the equation of this function. So I'm going to write f of x because I've just told you it's a function. Which basic function is represented in example 1? Which shape is that? It's the absolute value. It's the V shape. Would everybody agree with that? You can go back and play matching like we used to when we were in elementary school, the matching games. Those are fun. I wish I could still do those. Okay, we're matching. This is the absolute value of x. But now that isn't the graph of the basic function. Something's been done to it. What's been done to the absolute value? Where's it gone? It's gone up how many units? So what am I going to put after the absolute value of x right there? Perfect. Excellent. Well done. Hey, Perkster. I'll get to your question in just a sec. I started first. Sorry. Hey, Perkster. Can I put the +4 inside the absolute value? No, that means something completely different. We're going to talk about that. What's your question? The slope-intercept form, there's a relationship there, yes, because if you remember that from your intermediate algebra, the y-intercept is basically how far up has this gone, so it's very similar. Yes, the slope is what the slope represents, and we'll see this next Wednesday, and we can talk about it a little more, a stretching or a shrinking of our identity graph. So yeah, so you're spot on with that observation. What I would like you to do, please, is the next one, example 2, something very similar. Just write the equation that is represented there. I'm just going to use a different function letter. If you did or didn't, it doesn't matter at all, but I'm just distinguishing this from the previous example. So I'm going to call this g of x. What is the basic function that you can see there? What's the shape? Again, it's absolute value. No tricks or gimmicks. I'm just asking you these questions. And what has been done to the absolute value graph this time? It went down how many units? It went down 3, I think. But I have an eye appointment in a couple of weeks, so who knows what's going on with my eyes. So we're going down 3, so that means I do what with my value? Minus, I subtract it, yes. Before I turn the page, any questions, comments, or concerns? All right, I'm flipping the page. Now we're gonna do something a little different. We'll come back to our basic functions in a minute. So example 3, this is my example. But before I do my example, please do me a favor. up above the word example here, so it's out of the way, write down what the domain and the range of my graph here that I'm starting with is. All right, domain, x values, left and right. How far left does this graph go? -4. And how far right does this graph go? +4, yes. And then the range, y values, how far down does this go? Again, -4, I wasn't super creative, I guess. And then how far up does it go? Awesome, well done. Okay, here's what we're going to do. This is my example. That is this graph right here. This black graph represents my basic function. And so I've happened to have a different color. Your pencil will be lighter, so it'll represent a different color. What we're going to do is we are going to graph f of x plus 5. And so at first, since we're just learning this, what we're going to do is we're going to go point by point and make this adjustment. So you tell me what the adjustment is. This says I'm going to take my function f, and what am I going to do to my function f? Add 5 to what? The y values. Yes, we're moving it up. Okay, here we go. So this first point is at a y value of 1. So I'm just going to count 1, 2, 3, 4, 5, and I'm going to make a new dot. The second point is at a y value 4, so I'm going to go 1, 2, 3, 4, 5. I'm now at 9. The middle point is at 0, 1, 2, 3, 4, 5. The next one is at -4, 1, 2, 3, 4, 5. And finally, the last one's at -2, 1, 2, 3, 4, 5. Now I'm going to connect the dots. And there it is. So quick question about this graph. Have I changed the shape of this graph? Have I deformed the graph in any way? No. What have I just done? I've just slid it or translated it. That's what that means. Exactly as it is, I've just slid it up the graph a little bit. So if you get a new graph when you're doing this and the shape has changed, then you've probably miscounted the points. We won't talk about changing the shape until a week from now when we talk about stretching and shrinking. Before I have you do an example, let's talk about the domain and the range of this new graph. And then we'll talk about the shortcut where you don't need to graph it to find the domain and the range. So looking at the new graph, left and right, the domain, what's the lowest x value? Still -4. What's the greatest x value? Still +4, yes. Notice we didn't move the graph in the x direction, so the domain didn't change, which hopefully makes sense. The domain is the x values, and we didn't move it in the x direction. How about the range? What's the lowest y value of my new graph? 1. And what's the highest y value of my new graph? Perfect. And hopefully that makes some sense. What did we do? We added 5 to all the y values. So the shortcut here is if you get a problem on your homework or on the test and says, here's the domain and range of the original function, and I move the function up 5 units, what's the new domain and range? You don't have to graph. All you got to do is go back to your range and say, okay, if I move the y values, I'm going to add 5 to the low end, and it moves up to 1. I'm going to add 5 to the high end, and it moves up to 9. Okay, so that's how the domain and range are going to work. So I would like you to do the same thing for me. Example 4, the one right next to it. I would like you to do 2 things. First, I want you to write down the domain and the range of that graph. And then I would like you to please graph what is g of x minus 6. I made that up. Yeah, that was. Yeah, if you wanted to make up another one, you could do f of x plus 2. Yeah, it's just the example I picked for us to do. Domain and range. So of the original graph, the domain is the x values. So the furthest left this goes is -4. The furthest right this goes is +4. I seem to have been stuck when I made these examples. And then the range, the y values, the furthest down this goes is -3, and the furthest up this goes is +3. So now I'm going to take this graph and I'm going to move it down 6. Hopefully that's what you said when you saw the -6. So here we go. 1, 2, 3, 4, 5, 6 right there. 1, 2, 3, 4, 5, 6 right here. Then -6 right here. 1, 2, 3, 4, 5, 6 right there. Bless you. 1, 2, 3, 4, 5, 6 right here. And now I'm going to remember the shape of the graph doesn't change. I'm going to do my best to replicate that. And there's my graph. Now you can either use the graph, or you can remember what we just said. We have moved the graph down 6, so the domain is not going to change at all. It's going to stay -4 to 4, and the graph does reflect that. And now the range, since we moved it down 6, I can just subtract 6 from each boundary point. And again, the graph represents that as well. So when I start at -3 and I subtract 6, that's -9. That's my new lower bound. And indeed, that is the y value of this point way down here. And then when I subtract 6 from the upper bound, I get -3. And again, that is the upper bound of the pink graph that you can see right there. We doing all right? I just want to make sure this sinks in. So this next one, example 5, I would like you don't have to worry about the domain and the range on this one. I'm hoping that feels pretty good because we talked about domain and range in the first unit. I simply would like you to do h of x here. That's the name of this function, plus 3. Just for my edification, the plus 3 is going to do what to this graph? Up 3, yes. So here we go. So 1, 2, 3. I'm going to move that point up. This one, this point down here, 1, 2, 3. This middle point, 1, 2, 3. And then finally this other end, 1, 2, 3. I'm just taking each of the points that I see and moving them up 3. We're going to do 2 more, and then we're going to move on to horizontal translations and recognizing them, and then we'll end with a flourish of doing it with both. Now this graph, what's slightly different is this graph right here doesn't have endpoints. It has arrows. It does not affect anything that I do on this whatsoever. So I would like you to please, this function's called k. I would like you to do k of x, and let's do -4. The -4, I'm hoping you all by now, you recognize that's going to move this graph down 4. So now I'm going to take each of the points that I have, 1, 2, 3, 4. I'm just going to move them down 4 units. This one, 1, 2, 3, 4, and then finally 1, 2, 3, 4. And then I'm just going to do the same shape on this graph that there is on the one above it. So I've got this, I'm going to put an arrow here. I'm going to connect the dots going up, and then it was constant going to the right. So I will keep it constant, and there we go. So even if it has not dots on the end, but arrows, it doesn't change anything you do. Just find the points you recognize and shift them. And that takes us to our last example. If you flip back to page 1, our basic graph, the square root. So I would like you to take our square root function, and I'd like you to do the square root of x, and let's do +6. So I'm just going to take my square root function, and we've got my 4 basic points that we graphed earlier in our time together. And I'm just going to move each of these points up 6 units. And there we go. Same shape as before. It's just been moved up 6. Before I move on to horizontal translations, does anyone have any final thoughts or concerns or anything we need to address about vertical translations? Plus moves up, minus moves down. Nice and straightforward. Okay, so back to page 3, the very bottom. So horizontal, wave your hand. Horizontal's what direction? Okay, left and right, like the horizon. It's the way somebody a long time ago taught me to remember that, which is good because I'm a slow learner. So horizon is left and right. Now, here's what you got to be careful of. The horizontal translation is not quite as intuitive as the vertical, right? Vertical plus meant up, minus meant down. Be careful. So for instance, if my constant is positive, again, then f of x minus c. So notice first, this time the constant is being applied directly to the x this time. That's how you know it's going to be a horizontal shift. Okay, is the adding and subtracting is done directly to the x. But what you have to be careful of is f of x minus c represents a translation right c units. I know if you're like me, when I first learned this eons and eons ago, okay, I saw the minus c and I said, oh, if vertical minus meant down, then minus c on the x is going to mean go left, go in the negative direction. Okay, but it's the exact opposite of what you would expect. Okay, so that's the thing you got to remind yourself. Okay, so I have a minus c, I'm subtracting c from the x values. That means I'm going right, I'm going in the positive direction. Now there's a mathematical reason, but I don't think it's necessarily worth diving into here with the time that we have. If you'd like to hear it, come by the office sometime, we can chat about it. So similarly, f of x plus c, okay, when you see the plus c, it does not mean go in the positive direction, okay? Break that habit for the horizontal direction. This represents a translation left, or in the negative direction, c units. I understand why that is tough to learn. I get it. Okay, it doesn't seem kind of natural. So you just have to, that's why practicing is important, to break yourself of the habit that you might want to develop. Okay, when it's going to be the same thing when we talk about stretching and shrinking. When we do vertical stretching and shrinking, okay, it's going to look, what you see on the function, it's going to be exactly what you would expect. But when you do it in the X direction, horizontal, it's going to be the reverse as well. Okay, so that's kind of the pattern that you have. When you do things in the X direction, it's going to be opposite. So we're going to do the same sort of thing that we did a second ago. My next example, example 7. I've given you the graph of the function. It's one of our basic functions. And we are going to write the equation of this. Okay, so, f of x. Well, first, tell me which basic function, what's the shape of that represent? My squaring function. Now, this time, my squaring function has been moved where? It's been moved to the right. It's moved in the positive direction 4 units. So since it's moved in the X direction, I'm going to leave a little space inside my parentheses because I know I'm doing something to the X value. And if I've moved it right, what am I doing to the X? It's going to be X, perfect, minus 4. If you wanted to say plus 4, I totally get that inclination. But it's minus 4. It's the exact opposite of what you would think just from following our earlier pattern. Yes. We'll get there. You're ahead of the game. I love it. We're going to talk in depth about parabolas in either chapter 3, chapter 4, and we will talk, if anyone heard him, he said vertex form. We are going to talk about putting our parabolas in vertex form when there's all sorts of fun stuff done to them. All right, what I would like you to do, same thing, example 8, if you wouldn't mind, please just writing down what the function notation for that is. Again, I think we would all say that this is the squaring function. And I've moved it to the left. So that means what am I going to do to my X value this time? Okay, plus, and it's 6 units. Yes, exactly right. Well, I'm going to assume maybe it's a bad assumption, but we'll see in just a minute. I'm going to let you go with the next one. So what I would like you to do, we're just going to do the domain and range of this first problem. So first thing I would like you to do is what's the domain and the range of example 9? I think we already did that, but you can write it down again real quick. And then after you've done that, I would like you to graph f of x minus 3 and write down what its domain and range are. For our domain and range, you might have just flipped the page backwards. I think this is the same function we've already used one time. So the domain is -4 to 4, and the range is -4 to 4. I wasn't really creative with that. So now I've got the f of x minus 3. So this minus 3 in here attached directly to the x means I'm going to do what with this graph? 3 units which way? To the right. Yes, the positive direction. Perfect. Okay, x minus 3 means go 3 units to the right. So I'm going to take each of these, 1, 2, 3 right there, 1, 2, 3, the middle, 1, 2, 3, this 1, 2, 3, and finally 1, 2, 3. And again, just like our vertical translations, the shape of the graph is not changed at all, just its position. This time I move the graph in the x direction, so which is going to be affected, the domain or the range? The domain, okay, since I've messed with the x values. And just like with our range, if you don't want to look at the graph, you can just do the change right here. I moved this to the right, meaning added 3 to all the x's. So that means my low bound of the domain is going to be 1, my high bound is going to be 7, and the graph should back that up. I have not moved this particular graph at all in the y direction, so the range is not going to change at all. We'll do one more domain and range when we do both things in just a minute, but I'm not going to do another domain and range for just the x direction. So before we do our next problem, is there a question about where the domain and the range came from? All right, for this next one, example 10, if you wouldn't mind, please, or I guess even if you would mind, that's fine. I would like you to please do g of x plus 5. So the x plus 5, that plus 5 attached directly to the x tells me what am I doing with this graph? Left, exactly. Yes, you're catching on. I love it. 1, 2. Oh, hang on, I can't count. 1, 2, 3, 4, 5. There we go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and one more. 5. Whee! Oh, I missed the dot. Sorry. Do the best I can. All right, flip the page. Just a couple more, and then we are going to end with a flourish of fun problems where we do both. So this one right here, h of x, if you wouldn't mind doing h of x minus, let's go x minus 5 right there. X minus 5, this is going to take the entire graph right 5 units. So 1, 2, 3, 4, 5 for that first point, and 1, 2, 3, 4, 5 for the second. 1, 2, 3, 4, 5. Lots of counting here. 1, 2, 3, 4, 5. We're right on the end of the graph. And here is my lovely graph. K of x, the one right next door, please do k of x plus 1. We're not moving it very far, just a little bit. So the x plus 1, this is going to move the whole graph to the left 1 unit. So each of these points that I've defined for you are just going to go left 1. And so the graph, remember, is the exact same graph. And it's just moved left. And there it is. One more of these, and then we're going to talk about what happens when both are done. So if you go back to page 1 again, okay, page 1 are basic graphs. We're going to look at the cubic graph. And please, if you would, do x minus 3 cubed. So as you're doing this, and maybe you're finished up, please notice the difference between the vertical and the horizontal translation. Over here, this was the vertical translation. The plus 6 was outside of the function. This square root did not extend over the plus 6. Okay, that would have meant something different. Here, this is a horizontal translation. The minus 3 is attached to the x. It's inside the function. So there's a difference in the way these things look. So this is going to tell me to move everything to the right 3 units. So up at the top, I go right 3, and then here, right 3, right 3, right 3, and then finally down at the bottom, right 3. And there's my graph. All right, we're doing good, doing great on time. What I would like you to do is this. Example 13, this is back page 5. I'm gonna have you do this problem, but the way I want, first off, before we get started with the problem, I don't know why I didn't put the basic function on there. This is the same function f we've been using. So the points, you can flip back and forth, or here are the points -4 and 1, -2 and 4, 0, 0, 2 and -4, and 4 and -2. I'll connect the dots in a minute, but that's our basic graph. And then we just connected the dots like this. It's the same thing we were using earlier. Before you get started with our translation that we're going to do here, I would like you just up by the function up here, just write down what you hypothesize is happening. We've got an x minus 3 and a plus 2 on this. So write down your summary that you're going to follow when you do the graph. Which points do you want? So this graph, doesn't matter what order. Tell me one of the 2 things happening to this graph. Okay, let me go over the points. I think I did that too fast. So I'm sorry about that. I should have put the graph on there. So this first point right here, this is -4, 1. This second point is -2, 4. This third point is 0, 0. This fourth point is 2, -4. And then this fifth point, the last point, is 4, -2. Then what I asked you to do is to tell me the two things that are happening to this graph. So what's one of the two things happening according to what I have written here? What did you say? Somebody over here said something. Okay, right 3, and then you said up 2, so great, we've got it. So this -3, since it's inside the parentheses, that tells me the graph is going to go right 3 units. And then the +2 on the end tells me that I'm going to move all the points up 2. Okay, so you're climbing some steps here. So go ahead and do that with those 5 points. Take each of the points, go right 3, up 2, or up 2, right 3. Doesn't matter what order you do that in, you're going to be in the same place. So we're going to move right 3 and up 2. So 1, 2, 3 to the right, and then up 2. That's my first point. Right 3 and then up 2. There's my second point. I'm going to take the origin, right 3 and then up 2. This fourth point, right 3, up 2. And then finally this last point, 1, 2, 3, and then up 2. So again, we're just translating the graph. We have not changed the shape of the graph at all. Okay, we have slid the whole graph right 3 and then up 2. Down at the bottom, if you would please, we've already done the domain and the range of this particular graph a couple times, so you can flip back or you can read it again. But what's the domain and the range of the new graph? For this graph F, we've seen a couple times already that the domain is -4 to 4 and the range is -4 to 4. Okay, we've written that down before. So now what's the domain of the new graph? Well, we moved the graph right 3, meaning we added 3 to all the X values. Okay, so that's going to affect the domain. And you can look back up at the graph and read it there. But I'm just going to use this when I move -4 right 3, when I add 3, that takes me to -1. That's my lower bound. And when I move 4 right 3, when I add 3 to that, it moves me to 7. And that agrees with my graph that we've got up there. The domain is now -1 to 7. And then we went up 2, so the range is going to be changed up 2 units. So my lower bound was -4. So when I move that up 2 plus 2, that is -2. And then the upper bound was 4. When I move that up 2, that is 6. And again, that agrees with my graph that we have there, that it goes now from -2 to 6 in the y direction. One more on this page. This is my graph of G. I'll do slower. I'll do a better job for you this time. I'm sorry about last time. So this first point on the left, again, I don't know why I didn't put the graphs here, but that's my fault. Negative 4, 0 is the leftmost point. Negative 4, 0. The next point is negative 2, 3. So that's negative 2, 3. The next one is 0, 0 right there in the middle at the origin. The fourth one is 2, negative 3. 2 in the X, negative 3 in the Y. And the last one is 4, 0, 4, 0. And then just a little curvy shape connecting the dots. Did I do better that time? Everybody get that? Okay, so do me this favor. I would like you to please just do this whole problem. First, graph G of X plus 4 minus 6, and then do the domain and the range down at the bottom. From the equation or from the function notation, what two things are happening to this graph? Left 4, wonderful, love it. Excellent, well said. Left 4, down 6, perfect. So I'm going to take each of these points, left 4, 1, 2, 3, 4, and then down 6, 2, 4, 6. I think that's there. Left 4, 1, 2, 3, 4, down 6, 3, 6. Left 4, down 6. Lost count, there it is. And then left 4, 1, 2, 3, 4, and 2, 4, 6. And last but not least, left 4, 1, 2, 3, 4, 5, 6. So again, the shape is not changed. It's the same shape graph. It is now just moved left 4, down 6. From previous problems, or just from looking at the graph, the domain is negative 4 to 4. The range is negative 3 to 3 of the original graph. Now my new graph, I moved left 4, down 6. So the domain is affected by the left 4. What was that? If I move negative 4 minus 4 more, that's going to be negative 8. And then when I take 4 minus 4, that is going to be 0. Okay, so negative 8 to 0. And then the range is affected by the minus 6, the dropping it down 6. So the negative 3 minus 6, that's going to be negative 9. And then the 3 minus 6 is going to be negative 3. And again, both of those things are validated by our graph. So we are all set. I've got 2 more problems for us. You're almost done with me for the day and for the week. So happy end of week 3. Wow, the semester's flying by. Only 13 weeks to go. So here's what I'd like you to do. We're going to go to example 17. First column, the middle problem. Says we're going to graph this right here. So here's what I would like you to do. We're going to do this in 2 phases because I don't think you've practiced enough yet to do this all in one step. If you have, fantastic. What I would like you to do is graph the basic function like we did at the beginning of class, and then graph the +2 -4. So which basic function is this? Absolute value. So real quick, graph the absolute value, practice that, and then graph absolute value of x + 2 -4. Okay, I'll give you a couple minutes to steamroll through that. Here's my basic function, my v, just transcribed from the front page or just reproduced from memory. And now what 2 things am I going to do to my v, to my absolute value function? That is exactly right, left 2 and then down 4. Yep, I'm going to take the whole thing, left 2, down 4. So I'm going to start with the origin, doesn't matter what points. I'm going to go left 2 and then down 4. So there's my point. Something that you can get in the habit of, I'm just going to tell you a little shortcut. When I'm doing these problems, what I would do, my process would be to say, okay, my origin has moved left 2, down 4. Now, nothing else has changed about this. The shape has not changed. So then I would just do my V from right there and treat that as my new origin from my basic points. Okay, so if you can do that, great. If not, that's great too. So I'm going to take all my points, left 2 and then down 4. And then left 2 and then down 4. One more time, left 2 and then 4. And then on the other side, left 2, down 4. Left 2, down 4, 1, 2, 3, 4. And finally, last but not least, left 2, down 4. That's this point. And there's my V. Same shape as before. I've not changed the shape, although I did miscount. You can see on that problem right there. 1, 2, 3 should have been right here. That's why I need to go to the eye doctor in a couple weeks. So that's happening. Okay, so there we go. Last problem for the day. What I'm going to do after you leave, so this can be part of your homework. if you want. I'm going to record these last two problems at the bottom when you leave. So I'll post it on Canvas. If you want to try those out for homework, then you can see me work them if you feel a little insecure about doing these problems on your own. So in the meantime, this is my square root graph. So I would recommend writing down the square root graph, doing the basic function first, and then doing whatever that says. I would recommend just using the points from the basic functions. That's why I've been meticulous about doing each of those so that you have enough reference points when you move it around. So that's good. That'll be really helpful when we do the stretching as well. Then if you finish up the graph, I noticed right below I asked about the domain and the range, and that's something interesting on this problem. So yeah, if you got time, fill in what the new domain and range are of the graph. Here's my basic graph right here. I've got 4 points. I would recommend using all those points so we can keep the general shape. So on this graph right here, I'm moving it left 7 and I'm moving it down 2. So I'm going to take these points, left 7. So this goes all the way to -7 and then down 2. This next one goes all the way to -6 and down 2. This one starts at 4. So left 7 is going to move it to -3, down 2. And last but not least, this one that's at 9 is going to go all the way over to 2 and then down 2. It's right there. Whee! There's my new graph. The domain and the range. Well, the domain is how far left does this go? Well, since my old domain started at 0 and I moved it left 7, my new is -7, and you can see that on the graph. When you subtract 7 from infinity, you know what you get? Infinity. So that does not change. Okay, it does not affect the upper bound of this at all. So there's my domain. The range, when I move this down to, you can see my lowest y value is -2. And again, when I subtract 2 from infinity, I still get infinity. So there's my domain and my range. All right, as I